Greetings, friends. Welcome to a new episode of Declutter. In today's episode, I will walk you through the solution to one of a very important and interesting cryptograms that I came across while browsing through some videos on YouTube. In this cryptogram, we will be testing around our understanding and application of divisibility tests and squares and square roots. Both these concepts are taught to us when we are in school in grade 8. However, we don't really learn how to use these concepts on interesting and difficult questions. What I've also done is I've posted the same question on my Instagram handle. If you don't follow my Instagram handle, go and follow it right now for some very interesting questions that you will get to solve. My handle is Decluttered. All right, without wasting any time, let's go and look at what the question is and then solve it. All right. So the question goes as is. If A and B are digits from 0 to 9, find the value of X such that the 4-digit number AABB is a perfect square. Interesting? If you want to attempt this question, please pause the video here, go and try it, and come back for the solution that I present. All right, let's look at the solution. If we look at it from our concept of permutations and combinations, we will know that the total number of solutions possible to this is 9 into 9, because A can take 9 digits, 1 to 9, A cannot take 0, and B can take 9 digits, all digits including 0, but those which are not equal to B, not equal to A. So the total number of possible solutions are 81. Whoa, I'm not going to do a hit and trial for 81 possible probable solutions. Let's see how we can simplify it using just two concepts of divisibility rules and concept of squares and square roots. If we look at the digit or the number AABB, it's interesting to note that this number is divisible by 11. Why? Because sum of alternate numbers are A and B, and the difference of these is A plus B minus A plus B, which is 0, and this is divisible by 11. It's a very fundamental divisibility rule for 11. All right. So I can write AABB as 11 into A0B. You can try for any number. Let's look at 2233, right? This is equal to 11 into 203. Take any other number. 5522. This is equal to 11 into 502. Great. All right. So we have written this AABB in the form of 11 into A0B. Now, by using the next fundamental concept that since this number is a perfect square, we can say that AOB should have 11 as a factor. I have 11 power 1 here. So A0B should be written as 11 into some number. Let's call that number a question mark. Should be A0B. Yeah. Going back to the fact that if A0B has 11 as a factor, A plus B should be equal to 11. That simplifies the question. And honestly, we have brought the number of solutions down to 8 from 81. 81 to 8. A plus B is 11 has brought this. You can try hit and trial with A plus B is equal to 11 with the 8 possible solutions and check. However, I would like to take one step further on one more concept to reduce this further, such that a plus b is 11. If you remember the chapter squares and square roots, we have learned that a perfect square does not have the units digit as 2, 3, 7, or 8. You can check any perfect square. They will not have the units digit as 2, 3, 7, and 8, which brings us further, and we reduce a plus b is equal to 11 further down from 8 probable answers to 4 probable answers. Sounds good? We have just eliminated a lot more. So possible values of A and B are, if A is 2, B is 9. If A is 3, B is 8. This is not possible. 4, 7, not possible. 5, 6, 6, 5, 7, 4, or you also have 8, 3, again not possible. 9, 2, not possible. So the possible answers are 2, 9, 5, 6, 6, 5, 7, 4. The next step here is observe that 6, 5 is also not possible because a perfect square with 5 in the units digit will have the last 2 digits as 25. So the possible solutions are 2299, 5566, 7744. That's it. A quick factorization of them will show that 2299 is 209 into 11, which is 19 into 11, not a perfect square. 5566 is 506 into 11, which is 46 into 11. Again, not a perfect square. 7744 is 704 into 11, which is 64 into 11. And 64 is a perfect square of 8 square. So 7744 is your answer, which is equal to 88 whole square, and x is equal to 88. Fair? I will quickly summarize what we did in this question so that this is a very useful slide for you. How we simplified AABB is by first observing that this number is divisible by 11. So we wrote it as this. After that, we told that since this is a perfect square, A0B should have 11 as a factor, which brought us down to the fact that A plus B is 11. After that, we used the concept that a perfect square does not end with these digits, which eliminated B not equal to these. We also said B cannot be 5 because a perfect square ending with 5 will have 25 as the last digits. Using these, we were left with 3 solutions to check, and out of those 3 solutions, only one of them resulted in a perfect square. Great. If you enjoyed this, please like, subscribe, and share. And please spread the word around my channel for a better outreach. See you.